Good morning, everybody. So, as we know, in yesterday's class, we have seen work done by a constant horizontal force. Means, if I take any kind of object present in the surface, so for example, if this is the surface, and if there is an object present on the surface, and continuously a constant force is applied, that is what we used to say horizontal force. So horizontal force continuously applied so that the motion of the body is also in the same direction. So if the force is applied, then it will travel some distance and it will comes to the new position. So that is what from the point A to point B, let me take the distance between them is I will consider as a yes. So in this case, the work done if have been taken is equals to, what is the formula we have got it, everybody? Work done to move the
Force
body
into
from,
displacement.
yes. So the constant horizontal force F is applied, horizontal force applied on a body, which moves from point A to point B, getting displaced by S meters. So then work done is equals to a product of a force applied on a body into displacement shown by the body. So now, of course, you all knows, as I said, work is a vector quantity or scalar quantity. Everybody? Yes?
Scalar quantity.
Scalar quantity.
So remember, if you want to exactly write it here, so 11th class, you will get a two kinds of product. So basically, do the product means mathematics will do multiplication. Am I right, everybody? Is that right? So products in class 11th will get two things. One is dot product, another one is cross product. So you have to remember between any two physical quantities, dot will come. That is what dot product will say. If I write with a cross, you will get a cross product. But now I am not going to say you this because it is not required and you will get confused also. So basically, if you go now, work done is equals to force into displacement, you write. But if it comes to the class 11, you will write force dot F dot S. That is what work done is equals to force into displacement. So this is indicating a dot product. What is dot? What is cross and all? We'll study. So now it's not required. You just focus on it. So and then we studied what is the unit of work or work done? Everybody? Unit of work or work done? Joule. Joule is equals to how many Newton meters? All of you. 1.
Newton into 1.
Yeah. 1 Newton into 1 meter. Same way we have done for CGS system. So CGS system, what is the unit, everybody? 1 erg. So 1 erg is equals to how much it is?
9 into centimeter.
9 into 1 centimeter. And we all knows that 1 joule equals to finally how many ergs? All of you. 10 power 7 erg. I think this is not studied. Am I right, everyone? Correct? Yes or no?
Yes, sir.
Yes. So we all know. So let us see how to study. From here we'll start in our today's class. So 1 joule is equals to 1 Newton into 1 meter. Now, note it, everybody. 1 Newton is equals to 10 power 5 dynes. Okay, wow. Same way 1 meter is equals to how many centimeters? How many centimeters? 100
10 power
which is equals to 10 power 2 centimeter. That's all. So 1 Newton is equals to 10 power 5 dyne into 1 meter is equals to 10 power 2 centimeter. So now I'll write 10 power 2 into 10 power 5. How much it is? 10 power 5 plus 2 dyne centimeter. So 10 power 5 plus 2 means what? 10 power 7 dyne centimeter. is equals to how many joules? How many joules, Ra?
1 joule.
1 joule. So 1 joule is equals to 9 centimeter. But we want it what? Erg. So we all know 1 dyne into 1 centimeter is equals to how many ergs? Everybody. 1 erg. So 10 power 7 ergs is equals to, what is that? 10 power 7 dyne centimeter. That is what is the relation. Not ergs, erg alone. Any doubt till here, you can ask me, I'll explain. Are you clear, everybody?
Yes, sir.
Yes. So now, if the same force is applied inclined, then what is that? We will discuss now. That is what? At an angle with the horizontal. So all of you keep reading. Work done by a constant force acting obliquely. So what do you mean by obliquely, everybody? At
With an angle.
angle.
With an angle.
At an angle. At an angle with the surface. Prima. With the horizontal surface. So at an angle with the horizontal. So that is what we used to call it as a force applied on a object with some angle. So that is what obliquely we can say. So now, in this case, you have to remember mainly about a cos theta value. So trigonometry, if you have noticed it, so before starting this topic, actually you need to know that, but it's not required. Class 10th mathematics will study. So all about class 10th maths. So we all talk about trigonometric ratios. So trigonometry is talk about different ratios. In that, the most important ratio is sine and cos. So cos theta. So you need to know here actually totally 6 basic ratios will be there in trigonometry. So in that, the first one is sine. Second one is actually SIN is sine will represent as SIN. Second one is we can take cos. That is what cosine actually is named. So COSINE cosine will write as a cos. So this cos theta is very, very important. So now, we remember all of you, as we all knows that if the force is acting, I already taught you long back, force is a vector quantity or scalar quantity. Everybody? Force is a vector quantity or scalar quantity?
Vector quantity. Vector
Vector quantity. Now, I am saying you, now you notice it till end of your education, you cannot forget this. So now imagine if this, suppose, if this is the surface of the object. Clear, everybody? Now, note it again, I already taught you, but now again I am saying, suppose imagine if the force applied on this surface is in this inclination. Note it, everybody. Now, this is the direction of applied force. Then, this force experienced by the surface is exerting on 2 different surfaces. One is, that is what, 2 different angles. So that is what, one is F cos theta and another one is F sin theta. So that is what is important. So the horizontal component, if you have taken, so if you take basically whatever it is, so now the force is acting in 2 different directions. One is vertically and another one is horizontal. Are you clear, Amma? Please respond. So if the force, for example, if the force is applied like this direction, for example, like this direction, now, in this case, basically, we will try to apply the force in this case only. Suppose if this is the object, let me take, it is a toy car. Okay. Now, if you have noticed it, everybody, so what will happen, everyone? If there is a person who is applying the force in this direction, you have a small doubt also, you can ask me. So suppose if the applied force is in this direction, then the force exerted by him will act in two different directions. One is, you all can see that this is the surface. So now one is, this case, this is call it as a vertical component, because he is exerting with the force with the theta angle. So note it, everybody, vertical component, and this is a what component? Horizontal component. Okay, wow. So in this case, vertical component is F, and here is the theta, means then everywhere theta. This will become F cos theta, and horizontal component is F sin theta when backward. Now, same toy car, for example, there is a boy who is trying to drag. Imagine like he tied a rope and he is trying to apply the force in this direction. So he is trying to drag from the inclination horizontal, that is what, with the theta angle from the surface. Clear, everybody? So now in this case also the force will split it into two different directions. You have to take vertical component and as well as horizontal component. So now vertical component in this case, first we'll write horizontal component. Horizontal component, as it is here, is the theta, then this will become F cos theta and this will become F sin theta. Always remember, anything if I taken, suppose here is the theta, then applied forces, then this will become F cos theta.
So one doubt, sir.
F sin theta. Yes, ma'am.
So the force is acted downwards only, no, sir. From the person only, no, sir.
Yes, yes.
But
So
the
from
arrow
the
mark
person,
denotes
yes,
forward.
yes. From the person, from the vertical surface, you have to take the angle. Basically, here only it will come F cos theta, but the force is acting downward direction, so that parallel shift will come here. Okay, the shift of this one. Understand? That is what. Now here the force is applied in this direction. This is the direction of applied force. So now this force from
Sir,
the,
in that case, he is pushing. In this case, he is pulling it, sir.
yeah, it is pulling. Now he is here, it is a pull, and here it is a push. Do you understand?
Yes.
Yeah.
Yes.
So whatever it is, see, we are having a 4 different coordinates. So now you can, the force can act based upon the different situation. Suppose if I take this component, the force can be applied like this direction. Now in this coordinate, force can be applied like this direction. In this coordinate, force can be applied in this direction. In this coordinate, force can be applied in this direction. Do you understand what I'm saying? So now,
Yes.
wherever theta is coming, for example, here theta comes, then this is F cos theta and this will become F sin theta. For example, now here is the theta comes. Now, this will become F cos theta and this will become what? F sin theta. Understanding? So wherever the force is applying inclined surfaces, no need to get confused, everybody. Wherever you get force is applied inclined or obliquely or at with angle to the horizontal. Suppose this is the horizontal surface. I can apply force in this horizontal surface in any angle. I can apply like this, or I can apply like this, or I can apply like this. Do you understand what I'm saying, everybody? So force can be applied in this horizontal surface with any angle. That is what? Angle with horizontal. So then in this case, force is having two different cases. That is what? As it is a vector quantity, it has a two different components. So for us only, we will consider horizontal only the force is applied in this direction. You consider. So it has a two components. So horizontal component is F cos theta because this is the theta, and opposite one is what? Everybody? F sin theta. Okay, all of you?
Sir, in what condition does the sin theta and cos theta changes from horizontal component and vertical component, sir?
Only when the applied force, if you take, so wherever theta comes, for example, theta comes here, then here it is the F cos theta and opposite one will be F sin theta. Clear?
Yes, sir.
Yes. So let me consider only this case alone. So now if you notice it, so what is that actually? As the force is a vector quantity, force is a vector quantity. So if it is obliquely, means making some angle with the horizon. So horizontal surface. This is our horizontal surface. Do you understanding, everybody? So now this is what is our horizontal surface. So now in this case, sir, how we can say theta comes in either angle? Anything, they will mention, Lingesh. That is, they will specify in the question. Are you clear? Yes. So actually, if you want to say, it is a right angle triangle. Basically, entire trigonometry will talk about, okay? So right angle triangle. So if you have been taken right angle triangle, so we all knows right angle triangle means definitely one angle is how much? It will talk about right angle triangle. So any right angle triangle, this right angle triangle, or you can take this is. So this is a right angle triangle. So now right angle triangle means we all knows that you can take a. So this is the theta. This is the theta. So now this one we used to call it as a base, and this one we used to call it as a perpendicular. Perpendicular, and opposite one will be, we used to call it as a hypotenuse. So you will study in 10th maths, by the time you'll understand. So it is a what triangle? A right angle triangle. So right angle triangle means what is the angle here? One angle is how
90.
much? 90 degrees. Okay. So this is what you have to remember it. So based upon this only, everything will get it. Now if you notice this is actually half. If you have check it. So if I project it a vertical line, this is actually a right angle triangle. So that's all is allowed. So now, whenever the force is applied inclined to the horizontal, so force is having is a vector quantity. So it has a two components. One is horizontal component. So horizontal component, 11th class, first 2-3 chapters, this is entirely will come. By that time, any direction can be applied. But now you remember this alone. So that is what F cos theta. And vertical component. What is the vertical component, everybody? F sin theta. Understood? So that is what. Now, so in these cases, sir, what is the work done? So as I said, so now a boy is there who is pulling.
Oh, and doubt, sir.
Yeah.
Always the horizontal component will be F.
No.
cos.
Based upon, that's what I'm saying. Based upon the theta position. Do you understand, Mari? So I'm taking
Yes.
in this case, this is the theta. So now that
Yes.
is the reason I'm talking about it. Do you understand?
Yes, sir.
Yeah. So here is the theta. So imagine there is a boy who is pulling the car. So this is what will become F cos theta. And this is the what will become F sin theta. So if you notice it here, in these cases, so we all need to take the amount of work done. Write it, everybody. So work done is equals to, okay. So force into displacement into, so basically work done is equals to force into displacement. We all knows that. But now here, what is the force applied in the direction of displacement? This is the direction of displacement. So now in this case, what is the force acting here? F cos theta. Horizontal
cos-
component, that is
cos theta.
F cos theta.
Cos.
So work done is equals to horizontal component of force. Horizontal component of force into displacement. In the direction of force only displacement will be there. So horizontal component is what, everybody? F cos theta into S. So answer is, if you rearrange it, Fs cos theta. So this is the formula for calculating the amount of work done when the force is applied obliquely or force acting obliquely or at an angle with the horizontal. That is what we have to remember it. So now we are having a values also for this one. So just a few angles I will tell you. So if angle is 0, that is what? Horizontal. If angle is 0, so notice it, angle is 0 means cos 0. So cos theta value. So cos 0 is equals to 1. So that the formula will turns. Work done is equals to force into displacement. That's all. When by the time, if the 0 means what? Everybody can understand? What do you mean by 0? Means displacement and force. Both are in what? Both are in same direction. Right? So applied force horizontal to that. So that is what is indicating angle is 0. So if angle is 0, then cos theta value is 1. If angle between the applied force and displacement, then this will become F cos 30. So F cos 30 value. So cos 30 is equals to root 3 by 2. Next, cos 45 value 1 by root 2. Learn these values. Cos 60 is equals to 1 by 2. Cos 90 is equals to 0. And cos 180 is equals to
Sir, is it there for sin
-2.
theta also when it is
Yeah,
with horizontal?
sin theta, cos theta, everything it is there. You will study. Okay, Mark?
Sir, is it the same values?
No, different values. Sin it is different, cos it is different, and tan it is another different value. So everything
Yes.
will be different. How to calculate it, everything they will teach you that. Okay. So now you can make this. This is only for cos, because as we are studying, we have only cos importance. We are studying only cos values. Okay. So you might be understand by this time here, cos 180 minus 1 means in the sense of the work and applied force. The displacement and applied force is opposite. Applied force in backward direction, displacement is forward direction, like a applying brakes. So by the time the angle between them is 180 degree, so work done will become F into S into cos 180 is minus 1. So what is the answer? Minus F into S means, what is that? Force and displacement are opposite to each other. Do you understand, Amma? All of you? Please respond. So
So
that is
then can we say it as negative work done?
yeah, that is what we are going to study. Negative work done. Okay? Yes, that is. Do it. Anybody having any doubt, you can ask me. Make it quick. Alfin, understand? Darshan, Gokul?
Yes, sir.
Do it.
So the work done differs from the place the force acts, sir.
Wherever it is, that's what Mari. So these are general common. For example, if you have been taken, suppose there is a toy car. Now you try to apply the force in this direction, then definitely different work done. With this some angle work done. With some other angle, different work done. With some other angle, different work done. So every case you are trying to pull you're trying to pull, but definitely the amount of work done is not equal in every case. Do you understand what I'm saying?
Yes, sir.
Yes. So because angle is differs. So if angle is differs, definitely the total work done is also differs. Okay.
So when the force is acted horizontal to the surface, we can use normal formula F into S,
yes,
no,
yes,
sir?
yes. Or else you can write Fs cos theta also. Cos theta, theta is equals to 0. Cos 0 is 1. You can write, nothing wrong with it.
Yes,
Okay.
sir.
Yeah. Clear? So that is what. Now,
If we take cos 0
yes.
means the whole value will become as 0, no, sir?
No, cos 0 is 1. Cos 0 is 1. Means horizontally. You are applying force is horizontally. That's all it is.
Yes.
Yeah. So now, if you have noticed it here, so we have done two formulas. So work is equals to force into displacement, and work is equals to Fs cos theta. So now means here work is directly proportional to force, work is directly proportional to displacement. But here work done is depends on three things. Can you tell me what is the three things? It is depends on what? All of you. It is depends on magnitude of force and displacement, and also it is depends on what now? Everybody. Angle between the what? Angle between what, guys? Force and displacement. Okay.
Distance.
Displacement. So that is also, it is a factor which will affect the magnitude of the work done. So based upon this, so now we will classify the types of work done. So depend upon the angle only. That is very, very important. So types of work done. So based upon the angle between the force and the displacement, angle between the force and the displacement, will classify it into three different types. So that is what you have to write. Types of work done is depending upon the angle between the force and displacement. Very, very important. So depending upon the angle, that is what theta between the force and displacement, so the work is considered to be three different things. One is work done may be three different things. That is what positive, or next one is negative, and another one is what? Everybody, or zero work done. So everything positive work done or negative work done or zero work done based upon only depending upon the theta. So angle between the force and the displacement. So that is only how to remember it. I hope you all clear. Anybody having doubt, you can ask me till here. Understand? Pradhana, Darshana, everybody. So now positive work done. So let us talk about the positive work done. So positive work done means immediately your mind should says. So positive work done. If you have been done any kind of work, if when we can say positive, remember angle between the force and the displacement, and the displacement is acute angle. What do you mean by acute angle? Anybody can tell? Mathematics you might be studied. What
Less
do you
than
mean
90
by
degree.
acute angle?
Less than
Less than 90. That is what? 0 to 90 degrees. So
90.
0 to 90 degrees. It must be more than 0. Of course, 0 also. Or it must be less than 90. It should not be 90. It is less than 90. That is what you have to remember. So in this case, work done is positive or negative? Everybody. Work done will be, what is that?
Positive.
Positive. Okay. So in this case, as the work done is positive, cos theta is also, yes, please, positive. Clear? So if you have been taken, so the force can be applied in anything. So for example, I will take all of you observe. So there is a block.
So how can you say that if work done is positive, the cos theta will be also positive?
Yes, unless cos theta positive, how the work done is positive? Because formula everything is positive, then only you can apply the total work done is positive. Do you understand? All the
Yes, sir.
components are positive. So the values will speak, Mari. Till cos 0 to cos 90, all the values are positive. Verify for now.
Yes.
Yeah. So suppose this is the block at point A. Now, I applied the force. F, which is theta angle with the surface. Then, what is the Fs cos theta? Everybody, it is making theta. So what will happen? Applied force component. Component, everybody. What is the component here? This is only the component, horizontal component. What is the component? F, speak guys, F cos theta. And after certain time, it has been pushed up to here. Same object, don't think size is changes. Same object. So it is came to point B. So now, by the time the distance between the point A to point B is, let me consider as a yes. So now, in this case, so you all observe very carefully. In this case, so what is the work done, everyone? All of you. So work done is equals to Fs cos theta. So now if you have noticed it, so let me take that theta is anything. That is what theta is equals to, I am writing F cos theta. That is how the formula will come. For example, if theta is equals to, I will say 45 degrees, then the formula will be modified Fs cos 45. So if you all notice the table, what we have given. So cos 45 value, how much, everybody? What is the 45 value?
1 by root 2.
1 by root 2.
1 by root. So now, Fs into 1 by root 2. So that is what will happen. So now from this, for today's class, the beautiful one I want to say you is, when it is less work done, suppose you want to do some work, which case you need to do like simply. So if you are, suppose I ask you to lift a 10 kg object, you are doing more work and some other is simply lifting. So means in the sense of, definitely there is the way which they are lifting. So for example, if I have been taken, so now I'll ask, there is a big car or some toy car. I'll ask Mr. Mari to apply the force horizontally. Do you understand, Mr. Mari? Applied force horizontally. Do you clear? So in this case, what is our work done? Work done is equals to what? Force into displacement. Okay.
Displacement.
So Mr. Mari has done work which is equals to force into displacement, whatever it is, Mari. Now, the same toy car, I asked Mr. Kishore to pull same toy car. Okay. But Mr. Kishore is applied with an angle of, let me take it now, in the angle of 30 degrees. Okay. So from the horizontal surface. Now, the work done by Mr. Kishore is equals to F into S into cos theta. So F into S into cos 30. So cos 30 is equals to how much, Ra? Cos 30 is equals to root 3 by 2. Root 3 by 2. Now, you tell me, let me take work done by Mr. Mari is W1, work done by Mr. Kishore is W2. Now, same way, I asked Mr. Lingesh to apply the force. He applied the force in 45-degree angle. So that now in this case, work done W3 is equals to F into S into cos 45. So what is the value of cos 45? Check it, everybody. Fs cos 45. 1 by root.
1 by root.
Am I right?
1 by root.
Work done. Now, same way. Now, again join in the meeting, then only I will make conclusion. Next, work done by, let me take another person. I will ask Mr. Sam to do the force. Now, work done by Mr. Sam, if you have noticed it, F into S into cos 60. He applied by 60-degree angle. So, the work done by him, after this conclusion only you can leave. So, join back. So, Mr. Sam is made angle 60 degrees. So, now, in this case, work done is equals to F into S cos 60 value, how much? Verify it, everybody. Cos 60 value, how much?
1 by 2.
1 by root 2.
1 by root 2.
1 by 2.
1 by 2. Okay. 1 by 2 cos 60. So, means in the sense of F into S means, have you checked it? F into S means W1. Am I right? So, means in the sense of if the Sam is applied the force in a